Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chat. Hello Yasir, hello Srinath, hello Salit, Kavi, Subhasini, Ravina. Welcome back guys, welcome back. So give me some green signal from the chats, people, if all of you can hear me, if I'm perfectly audible and visible to everyone. Quickly, let me know in the chats. Quickly, let me know in the chats. Perfect, guys. Perfect, perfect. So as you all must be knowing, today we shall be doing one of the important topics of the physical chemistry, and it's going to be concentration terms. We shall be discussing the concentration terms, all the concentration terms with all the problem patterns. We shall be discussing molarity of dilution. We shall be discussing molarity of mixing. We shall be discussing molarity of ions, etc., etc. Every single thing which is related to concentration terms in physical chemistry. In the today's session, I'll be doing all the things here, right? So my dear students, whatever I'll be writing on the screen, I would want all of you to take a note of every single thing, because every single thing is going to be equally important in the today's session, right? So let me know in the chats, first of all, if all of you are ready for the session. Let me know in the chats if all of you are ready for the today's session. Quickly in the chats. Yeah? Perfect, people. Perfect. Perfect. Surely, Mehran, you can do that. Thank you, Munir. All right, people. So let's get going then. Let's get started. As I told you, I'll be starting exactly from the scratch, from the basics. We'll cover all the types of questions which can be asked from the concentration terms. And let me tell you, already I have marked all the questions. There are almost like 12 to 15 different types of questions which can be asked from concentration terms. So we shall be discussing them one by one, right? But before doing the questions, I'll first of all try to make you understand what these concentration terms are, what are the direct results, what are the shortcuts here by means of which you can solve the questions in lesser time. Yeah? So let's get going, let's get started. My dear students, before discussing the concentration terms, few basic things I would want to address over here, which I'm sure every one of you would be already knowing, and what those basic terminologies exactly are. Dear students, as you all must be familiar with the fact that when we talk about a solution, a liquid solution, solution is basically made up of two components, right? Solution is basically made up of two components. One is called as solute, another one that's called as solvent. Solution consists of basically two components, solute and solvent, right? How do we define solute generally? My dear students, generally, solute is defined as that component of the solution. It is defined as that component of the solution which is present in lesser amount. Which is present in lesser amount. So generally, solute is defined as that component of the solution which is present in lesser amount. And if I talk about solvent, solvent is basically defined as that component of the solution which is present in larger amount. Which is present in larger amount. These two things I would want all of you to remember from now on, right? Point number one. Point number two. My dear students, from now onwards, you are going to represent solvent by either 1 or A. Now, it's completely your choice to call solvent either 1 or A. We are going to represent solvent by number 1 or you're going to represent it by A. Similarly, solute. From now onwards, I'm going to represent with number 2 or letter B. Right? Why is that? Because we have a lot of relations in concentration terms. We have got a lot of results. Just to make those results easy for you, I want you guys to remember these two things. Solvent will be represented by number 1. Solute will be represented by number 2. Okay? Now guys, since I told you, solution is basically made up of two components, solute and solvent, right? This is generally present in lesser amount. This is generally present in larger amount, right? Now have a look on few more basic things. My dear students, I'm going to note few terminologies here. W, M, E and N. Do remember, W stands for mass of the substance. Mass of the substance in grams. Similarly, M stands for molar mass of the substance. M stands for molar mass of the substance, whose units are going to be grams per mole. Similarly, this E over here, it stands for equivalent mass. It stands for equivalent mass. And my dear students, N over here, it stands for number of moles. All these basic things, I'm sure you already know, right? So from now onwards, W stands for mass of substance in grams. M stands for molar mass of the substance. E stands for equivalent mass of the substance. And N stands for number of moles of the substance. Okay? Now try to understand. Try to understand. For example, I'm writing W2. Can you let me know what this W2 stands for? W stands for mass, 2 stands for solute. That means W2 stands for the mass of solute. W2 stands for the mass of solute, that too in grams, right? For example, I'm writing N1. You know, N stands for moles and 1 stands for solvent. That means N1 is basically the number of moles of solvent. The number of moles of solvent. In the similar way, for example, I'm writing M2. M stands for molar mass, 2 stands for solute. That means I'm talking about the molar mass of solute. Right? Molar mass of solute. So these are few basic things which I would want all of you to remember before starting this particular important topic, that's concentration terms. Right? Now, my dear students, one more thing. Since you know that solution is made up of solute and solvent, do remember mass of solution is always equal to the mass of solute plus mass of solvent. This is something which, again, I'm sure that all of you are already familiar with. That the mass of solution is always equal to that of mass of solute plus mass of solvent. So these were some basic things which I needed to start the topic concentration terms, right? Perfect. I'm sure it's clear to everyone. Now guys, let's get going. Let's get started with our actual topic. The first topic, the first concentration term which I'm going to discuss with you. What is that? That is the weight by weight percentage of solute. Or you can call it as the mass percentage of solute. You can call it as the mass percentage of solute. Now, first of all, how do you define the weight by weight percentage of solute or the mass percentage of solute? Let's have a look about its definition first. Then I'll make you understand what it exactly means. Well, first of all, weight by weight percentage of solute. It is defined as the mass of solute in grams. Mass of solute in grams present in 100 grams of solution. Mass of solute in grams which is present in 100 grams of solution. So that mass of solute which will be present in 100 grams of solution, that's something which you call as weight by weight percentage of solute. For example, if in 100 grams of solution there are 20 grams of solute, I'll directly say weight by weight percentage of solute is 20. If in 100 grams of solution there are some 40 grams of solute, I'll directly say weight by weight percentage of solute is 40. If, for example, in 100 grams of solution, there are X grams of solute, I'll directly say weight by weight percentage of solute is X. So what is weight by weight percentage of solute? It is that mass of solute in grams which is present in 100 grams of solution. I hope this is clear to everyone, right? Point number one. Point number two, try to understand what exactly I'm going to say. My dear students, imagine that this is the container, and in this particular container, for example, we have got a solution. Let's assume that we have got 500 grams of solution present in the container. Let's assume and imagine that we have got 500 grams of solution in the container, right? Now, my dear students, since there is solution in the container, that means there will be solute as well as solvent in the container, because solution consists of solute and solvent. So, since I have taken 500 grams of solution in the container, that means there will be solute as well as solvent in the container. Let's assume that in 500 grams of solution, let's assume there are 50 grams of solute. Let's assume there are 50 grams of solute. This is something which I'm assuming. Now, whatever I'm assuming, I'm going to write the same thing in the form of a statement. How exactly? I'm going to write something like this. My dear students, I can say 500 grams of solution. 500 grams of solution contains 50 grams of solute. 500 grams of solution contains 50 grams of solute. So can I say 1 gram of solution contains 50 divided by 500 grams of solute? Absolutely, I can say that, right? Now you tell me, if 1 gram of solution contains these many grams of solute, tell me what about 100 grams of solution? Can I say 100 grams of solution will contain 50 divided by 500 multiplied by 100 grams of solute? Now, dear students, if I ask you, what did I calculate? If I ask you, what did I calculate? You'll say that we calculated the mass of solute. Which is present in 100 grams of solution. And that mass of solute, which is present in 100 grams of solution, what do I call that as? We call that as weight by weight percentage of solute, right? So this is the mass of solute. Which is present in 100 grams of solution. And that mass of solute in grams, which will be present in 100 grams of solution, that's something which you call as weight by weight percentage of solute. So this particular term is giving you what? It is giving us weight by weight percentage of solute, right? Now you must be thinking, why did I do this? I just did this to make a result directly to calculate weight by weight percentage of solute. I did this so that in the questions you are not supposed to do like this. I'm going to make one result over here. Understand what that result is. My dear students, I'm going to write a result. Weight by weight percentage of solute is equal to weight by weight percentage of solute. This is the weight by weight percentage of solute. It consists of three terms. What was this 50 basically? This 50 was the mass of solute. So in the formula, the numerator will contain mass of solute in grams. In the denominator, there is 500. What was this 500? It was the mass of solution in grams multiplied by 100. So I'm damn sure you easily can make this result over here. So in the numerator, I'm going to write mass of solute in grams divided by, it's going to be mass of solution in grams multiplied by what? Multiplied by 100. This is the result which you are going to remember from now onwards to calculate the weight by weight percentage of solute. No need to do this kind of the stuff. Just remember one direct formula. Whenever you are supposed to calculate weight by weight percentage of solute in the solution, you just have to use this formula. Mass of solute in grams divided by mass of solution in grams multiplied by 100. As simple as that, right? Now, my dear students, at the same time, if I ask you how to calculate weight by weight percentage of solvent, can you make a result for this one as well? Absolutely, you can do that. First of all, how do you define the weight by weight percentage of solvent? It is basically that mass of solvent which is present in 100 grams of solution, right? Yeah, that mass of solvent which will be present in 100 grams of solution. That is weight by weight percentage of solvent. What is weight by weight percentage of solute? That mass of solute which is present in 100 gram solution. Similarly, that mass of solvent which is present in 100 grams of solution, right? So what should be the formula? The formula to calculate weight by weight percentage of solvent has to be equal to mass of solvent in grams divided by mass of solution in grams, and you are going to multiply it with 100. So this is the result by means of which we can calculate the weight by weight percentage of solvent as well, right? And dear students, just take a note of one simple thing. Do remember, weight by weight percentage of solute plus weight by weight percentage of solvent, it is always equal to what? It's always going to be equal to 100, right? It's always going to be equal to 100. I hope this is super clear to everyone. Yeah? And at the same time, one more thing I would want to share with you. Sometimes you'll be getting a statement in the question, and the statement will be in this format. For example, I'm writing 10% weight by weight of NaOH aqueous solution. This kind of the statement you'll get in the question. But my dear students, you should exactly know how to decode this sort of a statement. First of all, it's mentioned that aqueous. Whenever you are mentioned with the term aqueous, that means the solvent which we have used. That is water. Now, if water is the solvent, so automatically NaOH, it becomes your solute. So NaOH is present in water basically. We have introduced NaOH into water, then only we have gotten a solution. Yeah. So how do we decode this statement? 10% weight by weight of NaOH aqueous solution. It simply means that 10 grams of solute are present in 100 grams of solution. It simply tells you that 10 grams of solute are present in 100 grams of solution. My dear students, this 10 grams of solute, so you got to know the mass of solute, which I'm representing with W2. That is 10 grams. You got to know the mass of solution. Mass of solution is 100 grams. Now you tell me, if you know the mass of solution, if you know the mass of solute, can't we calculate the mass of solvent? It has to be 100 minus 10, which will come out to be 90 grams, right? Perfectly done. Yeah, perfectly done. Correct? At the same time, we got the mass of solute as 10 grams. If I ask you, calculate the moles of solute, it will be mass of solute divided by molar mass of solute, right? If I ask you, calculate the moles of solvent, it will be mass of solvent divided by molar mass of solvent, molar mass of water. As simple as that, right? I hope this kind of the statement, whenever you see it, you should be able to decode this statement. So this was my first concentration term. I'm not going to do the questions right now. First of all, I'll teach you a few concentration terms, and then we'll do the questions in the stretch, right? Perfecto. Moving on to the second concentration term. My dear students, the second concentration term, that is weight by volume percentage of solute. How do you define weight by volume percentage of solute? W by V percent of solute. It is defined as that mass of solute, the mass of solute in grams, which is present in, now I'm not going to write 100 grams, I'm going to write 100 ml. And 100 ml of what? 100 ml of solution. So that mass of solute which is present in 100 ml of solution, that defines weight by volume percentage of solute. Imagine that in 100 ml of solution, there are some 10 grams of solute. I'll directly say that weight by volume percentage of solute is 10. Imagine that in 100 grams of solution, in 100 ml of solution, there are, for example, 20 grams of solute. I'll directly say weight by volume percentage of solute is 20. As simple as that, right? Now, my dear students, try to understand. Try to understand. I said this is not called strength. This is weight by volume. Weight by volume is different. Strength is different. Okay. So let me tell you one more thing. Let me tell you one more thing. The way we derived the formula for weight by weight percentage of solute, can you derive the formula for weight by volume percentage of solute as well? Absolutely, right? So I can say weight by volume percentage of solute, that has to be equal. Mass of solute, I'm writing as such. Now in the denominator, I'm not going to write mass of solution. I'm going to write volume of solution. And this volume of solution has to be in ml multiplied by 100. This is the formula by means of which you can calculate the weight by volume percentage of solute. This is the formula by means of which you can calculate weight by volume percentage of solute, right? Yes? And at the same time, if I ask you, what about weight by volume percentage of solvent? How do you define it? That mass of solvent in grams, which is present in 100 ml of solution. As simple as that. Make its formula as well. Its formula is going to be mass of solvent in grams divided by volume of solution in milliliters multiplied by 100. This is the result by means of which we can calculate weight by volume percentage of solvent. Yeah? Right? Now people, try to decode this particular statement. I'm writing 20% weight by volume of NaOH aqueous solution. Can you decode this kind of the statement? Now read it carefully. Now it's not weight by weight. It is weight by volume. It is weight by volume. That means W is weight, V is volume. That means solute we have to take in grams, solution we have to take in ml. Solute we have to take in grams, solution we have to take in ml, right? In the similar way, check this. Solute we were supposed to take in grams and solution also in grams. But here, solute in grams, solution in ml. So how you are going to decode it? It means that 20 grams of your solute, 20 grams of NaOH are present in, I'm not going to write 100 grams, I'm going to write 100 ml of solution. As simple as that, right? So you should be able to decode this sort of a statement whenever you see it in the questions, right? Now, my dear students, I'm going to tell you one important result which you shall be remembering from now onwards, because it will ease out a lot of things basically while solving the questions. Do remember, I'm not going to derive the result. I'm just going to give you the result and we'll see its application afterwards. Derivation is least important. See, do remember, weight by volume percentage of solute. It is always equal to weight by weight percentage of solute multiplied by density of solution in grams per ml. This is one direct result with the help of which you can easily convert weight by weight percentage of solute into weight by volume, or weight by volume into weight by weight. This is one important result. There will be a lot of questions in which you will be given with weight by weight percentage of solute and you will be supposed to calculate weight by volume percentage of solute. Just use this particular result. Weight by weight percentage of solute multiplied by density of solution. It gives me weight by volume percentage of solute. As simple as that, right? Its application part you'll get to know in some time. Okay. Similarly, there can be weight by volume of solute given and you will be supposed to calculate weight by weight. Accordingly, you have to use this result. It is done and dusted, right? Now, my dear students, there is third terminology. There is third concentration term. What is that? That is volume by volume percentage of solute. Now, if I ask you, what is volume by volume percentage of solute? How do you define the volume by volume percentage of solute? Let me tell you, volume by volume percentage of solute. Have a look. The solute you have to take in ml and solution also in ml. See, the first terminology is always for solute. Second terminology is for solution. So solute we have to take in ml. Solution also we have to take in ml, right? Now, write its definition. Its definition is going to be simple. It's going to be volume of solute in milliliters. It's going to be volume of solute in milliliters, which is present in 100 ml of solution. Now, my dear students, imagine that we have got 100 ml of solution. Imagine in 100 ml of solution, we have got 10 ml of solute. So you'll directly say volume by volume percentage of solute is 10. Let's say in 100 ml of solution, there are 20 ml of solute. You'll directly say volume by volume percentage of solute is 20. Right? As simple as that. So that volume of solute in ml, which will be present in 100 ml of solution, that defines the volume by volume percentage of solute. Right? Now, try to make its result. Its result is going to be simple. Volume by volume percentage of solute will be equal to volume of solute in ml divided by volume of solution in ml multiplied by what? Multiplied by 100. So this is the result with the help of which you can easily calculate volume by volume percentage of solute. In the similar way, if I ask you, what about volume by volume percentage of solvent? That will be equal to volume of solvent in milliliters divided by volume of solution in milliliters multiplied by what? Multiplied by 100. So this is the result with the help of which we can calculate volume by volume percentage of solute and solvent. Right? Now, if I write one statement over here, my dear students, I'm writing something like this. I'm writing 20% volume by volume of NaOH aqueous solution. Can you try to decode this particular statement? Can you try to decode this particular statement? Now, I'm not mentioning here as weight by weight or weight by volume. It's volume by volume. That means solute, we have to take in ml. Solution, we have to take in ml. So, I'll be writing that 20 ml of solute, 20 ml of solute are present in 100 ml of solution. 100 ml of solution. You should be able to decode this sort of a statement as well. And you'll frequently see this sort of a statement in the questions. Right? Clear to everyone? Quickly, let me know in the chats if all the things are clear till here. I'm just teaching you the basics right now. Quickly. Yeah? Perfect. This was our third concentration term. Now, my dear students, there is fourth concentration term, which is strength. Strength is basically denoted by capital S. Strength is denoted by capital S. How do you define strength? Strength is also defined in simple terminologies. It is defined as the mass of solute, in grams, which is present in 1 liter of solution. Which is present in 1 liter of solution. Imagine in 1 liter of solution. Imagine in 1 liter of solution, there are 20 grams of solute. You'll say strength is equal to 20. Right? Imagine in 1 liter of solution, there are 40 grams of solute. You will say strength is equal to 40. Imagine in 1 liter of solution, there are X grams of solute. You'll say strength is equal to X. As simple as that. Now, can you make its result? Absolutely, you should be making its result. It's going to be mass of solute in grams divided by volume of solution in liters over here. This is the result with the help of which you can calculate the strength of the solution. Is this clear? Is this clear to everyone? Quickly, people. Right? Perfect. Now, similarly, I'm moving on to the fifth concentration term. Fifth concentration term. That is mole fraction. That is mole fraction. Right? Let's talk about mole fraction. If I ask you how do you denote the term mole fraction, it is denoted by this particular sign, which is pronounced as chi. It is pronounced as chi, right? Mole fraction. So first of all, how do you define mole fraction of solute? And how do you define mole fraction of solvent? It's again very simple. For example, you have got a container, and in this container, we have got a solution. Solution means there'll be solute as well as solvent in this particular container. Let's assume that N2 stands for the number of moles of solute in the solution, and N1 stands for the number of moles of solvent in the solution. Let's imagine that, right? If I want to define the mole fraction of solute, how exactly you're going to define it? It's going to be the ratio of moles of solute to that of total moles present in the solution, right? Similarly, mole fraction of solvent, number of moles of solvent divided by total moles present in the solution. As simple as that. If you just know N1, N2 value, put the values of N1, N2 in these expressions, you'll be getting the mole fraction of solute, you'll be getting the mole fraction of solvent, right? So how do you define it? It is defined as the ratio of, moles of a component to that of total moles present in the solution. To that of total moles present in the solution. Right? Now, dear students, try to understand one thing. You must have heard about a binary solution. What is a binary solution? Binary solution is the one which contains only one solute and only one solvent. Only one solute and only one solvent. Binary solution is the one which contains only two components. Out of those two components, one should be solute and one should be solvent, right? Now tell me one thing. For a binary solution, do remember one simple thing. For a binary solution, chi1 plus chi2, it will be always equal to 1. For a binary solution, chi1 plus chi2, it will be always equal to 1. You can check it out too. See, chi2 formula you have, chi1 formula you have, right? Perfect. Now let's see whether this formula is valid or not. Chi1 is n1 divided by n1 plus n2. Chi2 is n2 divided by n1 plus n2. Let's get to know exactly whether it will come out to be 1 or not. See, the denominator is same, so n1 plus n2 in the denominator. And in the numerator, it's also going to be n1 plus n2. Gets cancelled out, the value comes out to be 1 only. So do remember, for a binary solution, the sum of mole fractions, it will be always equal to 1. Yes? Perfect. Absolutely. Now, people, there is one more term. There is one more term which can be asked, right? And that's again a very simple term. Or let me not write it properly. Let me write it in the form of a note. My dear students, sometimes to confuse you, they'll ask you the mole percentage. They'll ask you to calculate the mole percentage of either solute or solvent. Do remember, mole percentage is nothing. It is just mole fraction is to be multiplied by 1000. That's all. Mole fraction is to be multiplied by 1000. You'll be getting what? You'll be getting mole percentage. Right? Sorry, not 1,100. It is percentage, right? So basically, sometimes they might ask you to calculate mole percentage. Mole percentage is nothing. It is just mole fraction multiplied by 100. For example, I'm asking you to calculate the mole percentage of solute. It will be equal to mole fraction of solute multiplied by 100. For example, I'm asking you to calculate mole percentage of solvent. It will be equal to mole fraction of solvent multiplied by 100. That's it. Right? That's it. Again, simple terminologies, basic terminologies. My dear students, if I ask you, what will be the units of mole fraction? If I ask you what will be the units of mole fraction, see, in the numerator you have got moles, in the denominator you have got moles, right? So mole fraction, it will be unitless quantity, right? So do remember, mole fraction, it is a unitless quantity. It is a unitless quantity, right? I hope all these things are clear till here. Now comes one important term. That is, I guess, the sixth concentration term or fifth? It's going to be the sixth concentration term, which is the most important among all. See, till now, I did not solve any question. I did not solve any numerical. Let me first of all teach you the concentration terms, then we'll be solving the questions, all the types of questions which can be asked from the concentration terms. Yeah? Right? Now guys, see, molarity, which is denoted by capital M. Molarity, which is denoted by capital M. How do you define the term molarity? It is defined as the number of moles of solute. The number of moles of solute present in 1 liter of solution. Number of moles of solute present in 1 liter of solution. Imagine if in 1 liter of solution there are 2 moles of solute. You can directly say molarity of solution is 2. Imagine in 1 liter of solution there are 10 moles of solute. You'll directly say molarity of solution is 10. How do you define molarity? Molarity is nothing, it is just the number of moles of solute which are present in 1 liter of solution. That's all. Now if I ask you, what should be the result to calculate molarity? The result is pretty simple. Number of moles of solute divided by volume of solution in liters. This is one of the result to calculate molarity of the solution. This is one of the result. Second result, number of moles of solute I can write as mass of solute in grams divided by molar mass of solute. In the denominator there was volume of solution in liters. Instead of that, I can write volume of solution in ml and I can multiply with 1000 over here. So this is my one more result to calculate molarity of the solution. Right? Similarly, I'm going to give you one more result. What is that result? Do remember it directly. No need to go for the derivation, etc. Remember the results and solve the questions directly with the help of those results. Molarity of the solution can be calculated like this also. 10 multiplied by density of solution in grams per ml multiplied by weight percentage of solute divided by molar mass of solute. This is one more result with the help of which we can calculate molarity of the solution. Well, is there any other way? Absolutely, there is one more way. Since few minutes back, I told you weight by weight percentage of solute multiplied by density of solution. That is equal to weight by volume percentage of solute. So you can say, you can write it like this as well. 10 multiplied by weight by volume percentage of solute divided by molar mass of solute. So my dear students, these are some important results, right, which are going to ease out a lot of calculation for you, right? These are some important results with the help of which we can easily calculate molarity of the solution, right? These are some important results with the help of which you can easily calculate molarity of the solution. And I'll show you their application in some time. You just take a note of all these results. Just take the note of all these results, right? Yeah? Perfect. Right, people? Now, try to understand a few more things. If I ask you, what are going to be the units of molarity? What do you think are the units of molarity? My dear students, units of molarity. Molarity is number of moles, and here you have got volume. So moles per liter. The units of molarity are going to be moles per liter. Or you can call it directly as molar. You can call it directly as molar. The units of molarity from now onwards, you are going to remember it as moles per liter, or directly you can call it as molar. Right? Now, what is meant by it? What is meant by it? Try to understand. My dear students, if I'm writing one statement, I'm writing 2 molar NaCl aqueous solution. Can you try to decode this particular statement? 2 molar NaCl aqueous solution. What does it mean? What does it mean? Quickly. 2 molar NaCl aqueous solution. First of all, it means that we are given with the solution which is NaCl aqueous, in which solvent is water, solute is NaCl, right? So the solution which we have, its molarity is 2. What does it mean? It means that 2 moles of solute are present in 1 liter of solution. 2 moles of solute are present in 1 liter of solution. I hope this is super clear to everyone, right? Yeah? At the same time, one more important thing, dear students. Try to analyze it. Do remember one more thing. Do remember, if you increase the temperature of the solution, let's say you have got one solution in the container and you are increasing its temperature. Imagine that you have got a solution, right? You are just increasing its temperature. Do remember, with the increase in temperature, volume of the solution also increases. When you increase the temperature of the solution, volume of the solution increases. And if the volume of the solution increases, that means molarity of the solution, it automatically decreases. So tell me one thing, whether molarity of the solution is temperature dependent or independent. It is temperature dependent, right? So do remember, whenever from now onwards you are going to talk about molarity, molarity is basically temperature. Molarity is temperature dependent. So when you change the temperature of the solution, molarity of the solution will automatically change, right? So basically, in short, you can remember like this. Any concentration term which involves volume in its formula. See, you have got different concentration terms. Every concentration term has got one formula, right? If in the formula you find volume, that means that concentration term is going to be temperature dependent. That's it. So that concentration term in which the formula contains the term volume, that concentration term is going to be temperature dependent, right? Yes? Perfect, people? I hope all these things are absolutely clear to you till now. Now, people, there are a few more things. Sometimes in the question, they might mention that we have got a semi-molar solution. Semi-molar solution. Sometimes they mention like this, that you're given with a semi-molar solution. Let me tell you, semi-molar solution is the one whose molarity is 0.5. Semi-molar solution is the one whose molarity is 0.5. Similarly, sometimes they'll mention that we have got a decimolar solution. Sometimes we will be given with a decimolar solution. Decimolar solution is the one whose molarity is 0.1. Sometimes they'll mention that you are given with a millimolar solution. Or before millimolar, let me write centimolar solution. Sometimes you'll be given with a centimolar solution. Let me tell you, centimolar solution is the one whose molarity is 0.01. Sometimes they might mention that we are given with millimolar solution. And let me tell you, millimolar solution is the one whose molarity is 0.001. Perfect. So be careful with these terminologies as well, right? Semimolar solution is the one whose molarity is 0.5. Decimolar, 0.1. Centimolar, 0.01. Millimolar, 0.001. Okay? Perfect. Perfect, people. Is that clear? Is it clear? Yeah? Perfect. All right. So this was about what? This was about molarity. The results are very important. Application part, you will see in some time. First, let's try to cover these concentration terms. Okay. Now, guys, there is one more concentration term. That is going to be our 7th concentration term. What is that? That is molality. Molality, it is represented by small m. Now, you must be thinking how to define the term molality, right? How do you define it? Simply, it is defined as the number of moles of solute. The number of moles of solute present in 1 kg of solvent. The number of moles of solute present in 1 kg of solvent. What was the difference in molarity? It was not 1 kg of solvent. In molarity, it used to be 1 liter of solution, right? Here it is 1 kg of solvent. The number of moles of solute which will be present in 1 kg of solvent, you'll be calling that as molality. Let's assume in 1 kg of solvent, there are 3 moles of solute. You'll say molality is 3. In 1 kg of solvent, there are 5 moles of solute. Molality is 5. In 1 kg of solvent, there are X moles of solute. Molality is equal to X. As simple as that. Now, results of molality, they are pretty much important. So do remember molality is equal to number of moles of solute divided by mass of solvent in kilograms. This is the first result. Second result, number of moles of solute can be written as mass of solute divided by molar mass of solute. Mass of solvent in kg. If I write mass of solvent in grams, then I have to multiply with 1000 over here. As simple as that. Now, are there few more results to calculate molality? Absolutely. The derivation of them is least important. You have got nothing to do with the derivation, right? You have got nothing to do with the derivation, right? I'm just going to give you the results. Remember those results. Try to apply those results in the questions and get the questions done in very lesser time, right? Now, the next result is to calculate molality. You are going to write 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution in grams per ml minus molarity multiplied by molar mass of solute. This is one more result which is utilized from which questions are asked. There will be few questions in which you'll be given with molarity and you will be supposed to calculate molality. Just use this result directly and solve the question. That's all. Similarly, there is one more result. Molality of the solution is equal to mole fraction of solute multiplied by 1000 divided by 1 minus mole fraction of solute multiplied by molar mass of solvent. This is one more result. There will be few questions in which you will be given with mole fraction of solute and you will be supposed to calculate molality of the solution. Use this result in that question. Or you'll find certain questions in which molality will be given and mole fraction of solute is to be calculated. Again, you will have to use the same result, right? Again, you will have to use the same result. So these are some very, very, very important results which you guys are going to remember from now onwards to calculate what? To calculate molality of the solution, right? Now tell me one thing. What should be the units of molality as per you? Units. In the numerator, you have got moles. In the denominator, you have got mass. So it's going to be moles per kg. Moles per kg. Or you can call it directly as molal. M-O-L-A-L. Molal. Right? For example, I'm writing a statement. The statement is something like this. I'm writing 2 molal NaCl aqueous solution. Can you try to decode this particular statement? Can you let me know what it means? It means that 2 moles of solute, 2 moles of NaCl are present in 1 kg of solvent. 1 kg of solvent. You should be able to decode these kind of statements as well. Perfect. Now we will at the same time, if I ask you whether molality is temperature dependent or independent, it is temperature independent term, right? Because look at the result. Nowhere you can find volume. There is no volume mentioned over here. If there is no volume in the formula, so if you change the temperature, volume will change. But there is not volume in the formula, so molality is not going to change. As simple as that. So molality is temperature independent and molarity was temperature dependent. So can I say molality is preferred? Molality is preferred over molarity. Can I say something like this? Because the value of molarity can change on changing the temperature. But molality cannot change on changing the temperature. Right? Molality always gives you the correct results. Molarity can change on changing the temperature. I hope this is something which you are going to remember from now onwards again. Perfect. Similarly, there are a few more things. Sometimes they might mention that we are given with a semi-molal solution. What is meant by semi-molal solution? Any solution whose molality is 0.5. That is semi-molal. Similarly, decimolar solution. Any solution whose molality is 0.1. Similarly, centimolar solution. Any solution whose molality is 0.01. Similarly, millimolar solution. Millimolar solution. Millimolar solution. Any solution whose molality is 0.001. Right? I hope all these terms are absolutely clear to every one of you. Yeah? I've not shown you a single question yet. Questions will do after 10 minutes. Right? All the types of questions I'm going to show you. Nothing will be skipped. Okay? I hope till here everything is clear. Now guys, there is one more consideration term. There are basically one consideration term, that is parts per million of solute. ppm of solute. Parts per million of solute. How do you define the parts per million of solute? How do you define the parts per million of solute? Quickly. Normality already I have taught you in redox reactions. Check the redox reaction chapter. There we have discussed oxidation state, equivalent mass, then concept of gram equivalence, then normality. Normality is something which I've already discussed. So I'm not going to discuss normality here again. Right? Okay, so parts per million of solute. How do you define it? It is defined as the mass of solute in grams, which will be present in 10 raised power 6 grams of solution. Which will be present in 10 raised power 6 grams of solution. So, if in 10 raised power 6 grams of solution, let's imagine that in 10 raised power 6 grams of solution, there are some 100 grams of solute. You'll directly say parts per million of solute is 100, right? It is basically the mass of solute in grams, the mass of solute in grams, which is present in 10 raised power 6 grams of solution, right? That defines the parts per million of solute. If in 10 raised power 6 grams of solution, there are some 500 grams of solute, you'll directly say ppm of solute is 500. Yeah, as simple as that. Now guys, what is the formula? Parts per million of solute is calculated like this. Mass of solute in grams divided by mass of solution in grams multiplied with 10 raised power 6. Similarly, if I ask you, what about parts per million of solvent? It is going to be equal to mass of solvent in grams divided by mass of solution in grams multiplied by 10 raised power 6. Right? Similarly, I'm going to write one more thing. There is something called as parts per billion of solute. Parts per billion of solute. How can you calculate parts per billion of solute? It's going to be mass of solute in grams divided by mass of solution in grams multiplied by. Instead of 10 raised power 6, only change it to 10 raised power 9. That's all. Right? Similarly, parts per billion of solvent is equal to mass of solvent in grams divided by mass of solution in grams multiplied by 10 raised power 9. That's all. Right? Perfect. Now, dear students, try to understand and analyze one more thing. Look at this particular result. ppm of solute is equal to this, right? ppm of solute is equal to this. Can I write it like this as well? Parts per million of solute. Parts per million of solute is equal to mass of solute I'm writing as such divided by mass of solution I'm writing as such. 10 raised power 6 I'm breaking as 100 multiplied by 10 raised power 4. I broke this 10 raised power 6 into 100 into 10 raised power 4. Now just have a look on this particular term. Did we discuss it in the beginning? Do we call this whole term as weight by weight percentage of solute? Absolutely, you call it as weight by weight percentage of solute. So do remember, parts per million of solute can be written like this as well. Weight by weight percentage of solute multiplied by 10 raised power 4. Correct? Similarly, you can write parts per billion of solute. You can write weight by weight percentage of solute multiplied by 10 raised power 7. Right? Parts per billion of solute is equal. You will break this 10 raised power 9 as 100 into 10 raised power 7. Then you will be getting weight by weight percentage of solute multiplied by 10 raised power 7. So these are some very, very important results, very, very important concentration terms, which you have to remember. More than sufficient. Now see, whatever results I gave you, how to utilize them in the questions. Yeah. Let's have a look how to solve the questions. Okay, the first question which is on your screen. The first question which is on your screen. Calculate the mole fraction of solute present in 10 raised power weight by weight of NaOH aqueous solution. So first of all, we got to know that the solvent is water and NaOH, that's your solute. NaOH is your solute, right? Yeah? Try to understand. Try to understand. 10% weight by weight of NaOH aqueous solution. 10% weight by weight of NaOH aqueous solution. How do you decode this statement? How do you decode this statement? How do you decode this statement? This statement means that 10 grams of solute, 10 grams of solute are present in 100 grams of solution. Right? 10 grams of solute are present in 100 grams of solution. Now, my dear students, 10 grams of solute. Can I say we got the mass of solute, which I'm representing with W2? So W2 is equal to 10 grams. Mass of solute is equal to 10 grams. If mass of solute is 10, mass of solution is 100, can you let me know what will be the mass of solvent? Mass of solvent will be 90 grams. Clear? Clear, guys? Clear? Now try to understand. What am I supposed to calculate? Mole fraction of solute. How do you calculate the mole fraction of solute? Number of moles of solute divided by total moles present in the solution. So can I say in order to calculate the mole fraction of solute, we need the value of N1 and N2? Yes, we need the value of N1 and N2. We do not have the value of N1 and N2 yet. So let's try to calculate the value of N2. What is N2? What is N2? Moles of solute. Moles of solute is equal to mass of solute in grams divided by molar mass of solute. Moles of solvent is equal to mass of solvent divided by molar mass of solvent. As simple as that. Now, mass of solute is 10 grams. Molar mass of solute, molar mass of NaOH, that is 40 grams per mole. The value came out to be 1 by 4. Number of moles of solvent is equal to mass of solvent, that's 90 grams divided by molar mass of solvent, molar mass of water, that is 18 grams per mole. The value comes out to be 5. The value comes out to be 5. You got to know the value of N1, you got to know the value of N2. So get the value of mole fraction of solute. It has to be equal to moles of solute, that's 1 upon 4 divided by moles of solvent, that's 5. Moles of solute, that's 1 upon 4. When you solve it, the value comes out to be 1 upon 21. So this 1 upon 21, this is the mole fraction of solute present in the solution, right? This is something which we were supposed to calculate. My dear students, for example, in the same question, if they would have asked to calculate the mole fraction of solvent as well, if they would have asked the mole fraction of solvent, how you would have solved it? You know, for a binary solution, chi1 plus chi2, that has to be 1. So I would say chi1 is equal to 1 minus chi2, which comes out to be 1 minus 1 upon 21. The value comes out to be 20 divided by 21. This is the mole fraction of solvent in the solution, right? Perfectly done. So this was the first type of question which can be asked, my dear students, right? The second type of the question. The second type of the question. Calculate the mole fraction of solute and solvent in 10% weight by volume of NaOH aqueous solution. Density of solution is also given to us, right? Try to understand. What am I supposed to calculate? I'm supposed to calculate mole fraction of solute, which has to be equal to number of moles of solute divided by total moles present in the solution, right? Now guys, right now I'm not given with weight by weight percentage of solute. I'm given with weight by volume. I'm given with weight by volume. Do you remember? I gave you one result few minutes back. Weight by volume percentage of solute is equal to weight by weight percentage of solute multiplied by density of solution in grams per ml. I hope you remember. Now, what is this weight by volume percentage of solute? That's 10 is equal to weight by weight percentage of solute. I'll be calculating multiplied by density of solution is 2 grams per ml. So from here, I will be getting the weight by weight percentage of solute will be 10 by 2. That comes out to be 5. So my first step is I converted weight by volume into weight by weight. Now try to decode this statement. What does it mean? It means 5 grams of solute. 5 grams of solute are present in 100 grams of solution. Are present in 100 grams of solution. So that means I got the mass of solute, which I'm representing with W2, right? I know the mass of solution. So what has to be the mass of solvent? Solvent mass is equal to solution ka mass minus solute ka mass, which will be 95 grams. Since you got W1, you got W2. If you got W1 as well as W2, can't you calculate N1 N2? Absolutely, you should be able to do it. N2 is equal to mass of solute divided by molar mass of solute. So N2 has to be equal to mass of solute is 5 grams, molar mass of solute is 40, the value is 1 by 8. Similarly, N1, mass of solvent divided by molar mass of solvent. So you got N1, you got N2, put the values in this expression and get the mole fraction of solute, right? And once you get the mole fraction of solute, you can easily calculate mole fraction of solvent as well. How come? Because you know, chi1 plus chi2, that's always equal to 1 for a binary solution. Yeah? Is it clear, people? Say yes or no in the charts quickly. Is it clear? Perfectly done. Let's move on to one more question. Look at this particular question. Look at this particular question. Calculate the weight by weight percentage of solute. So, as per the question, we are supposed to calculate weight by weight percentage of solute. This is something which we are supposed to calculate. In 1.5 molar CH3COH aqueous solution. So, we are given with the aqueous solution whose molarity is equal to 1.5. Since it's mentioned aqueous, that means solvent is water. So, this automatically becomes your solute. Density of solution is also given to us. 0.8 grams per ml. Right? Now, you tell me one thing. You tell me one thing. Do we have any result? Do we have any result which connects molarity with weight by weight percentage of solute? There is one result which I gave you a few minutes back. Molarity of the solution is equal to 10 multiplied by density of solution in grams per ml multiplied by weight percentage of solute divided by molar mass of solute. This was the result which I gave you a few minutes back only. Yeah. Now, people, molarity of the solution, we already know 1.5 is equal to 10. I'm writing as such. Density of solution is equal to 0.8. Weight by weight percentage of solute we need to calculate divided by molar mass of solute. Solute is your CH3COH and its molar mass will be 60 grams per mole. Now you got one equation, one unknown. So approximately after solving this, weight by weight percentage of solute will come out to be 11.25 approximately. This is something which I was supposed to calculate. That's all. Isn't it simple? Isn't it simple, people? That's why I kept on telling you all the time to remember all the results. If you do not remember the direct results which I gave you, you will have to utilize more time in order to solve the equation. If you remember the result directly, it will not take you more than 20 seconds to solve the equation. Yeah? I hope this is clear. One basic question which will keep you motivated all the time. One basic and simple question, nothing to do here. 2.8 grams of KOH are dissolved in 200 grams of water, right? So 2.8 grams of KOH are dissolved in 200 grams of water. Calculate molality of the solution. Now, first of all, tell me, among KOH and water, which one is present in lesser amount? KOH is present in lesser amount, so it has to be my solute. So mass of solute is given. Mass of solute is given. Even mass of solvent is given. Mass of solvent is given. Now, if I ask you, what will be the molar mass of solute? What will be the molar mass of KOH? 39, 40, 56. So it is 56 grams per mole. If I ask you, what is the molar mass of solvent? Solvent is water. Its molar mass is 18 grams per mole. What am I supposed to calculate? I'm supposed to calculate molality, right? If you remember, I gave you one of the result, W2 in grams multiplied with 1000 divided by M2 multiplied by W1 in grams. Correct? Now, W2 value, already you know, that's 2.8 multiplied by 1000 divided by M2. M2 is 56 grams per mole. W1 is 200, right? W1 is 200. It is just the matter of calculation. You are done. You got the molality of the solution. That's it. Nothing else to do. One simple and basic question this was. Let me move on to one more question. Calculate the molality of 20% weight by weight NaOH aqueous solution. First of all, try to decode this statement. It is 20% weight by weight NaOH aqueous solution. What does it mean? It means that 20 grams of solute, 20 grams of NaOH are present in 100 grams of solution. Right? That's how you decode it. Now, people, I got to know the mass of solute, which I'm representing with W2. So, mass of solute is equal to 20 grams. Mass of solution is equal to 100 grams. So, tell me, what about the mass of solvent? Solution ka mass minus solute ka mass. That gives me the mass of solvent. Right? That gives me the mass of solvent. Perfect. What am I supposed to calculate? I'm supposed to calculate molality. Do you remember any formula to calculate molality? Mass of solute in grams multiplied with 1000 divided by molar mass of solute multiplied by mass of solvent in grams. This was one of the result. So molality is equal to W2, that's 20 grams multiplied by 1000 divided by molar mass of solute. Solute is NaOH. Its molar mass is 40 grams per mole. W1 value, that's 80. Right? Matter of calculation. Solve it. Get the molality of the solution. Isn't it simple? Yeah. I hope you should be able to. I hope you can solve easily these questions. Look at this question. Calculate the molality of a 2 molar solution. So we have got a solution whose molarity is 2. Whose molality is to be calculated. Did I give you any result which connects molarity with molality? Absolutely, there was one direct result. No need to use brain at all. Just use the formula. That's it. You know it. Already I have given you the formula. See, molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution in grams per ml minus molarity multiplied by molar mass of solute. Molality is to be calculated, which will be equal to 1000 multiplied by molarity, that's 2, divided by 1000 multiplied by density of solution, that's given 1.2 grams per ml, minus molarity, that's 2, multiplied by molar mass of solute, molar mass of NaOH, that's 40. Again, a matter of calculation, solve it, get the molality of the solution. Right? Again, simple. Just you need to remember the results basically and try to utilize the results in the questions. That's all. Look at this particular question. Dissolving 120 grams of urea in 1000 grams of water gave a solution of density 1.15 grams per ml. Calculate molarity. As per the question is concerned, 120 grams of urea, 120 grams of urea is dissolved in 1000 grams of water. 120 grams of urea is dissolved in 1000 grams of water, right? When 120 grams of urea is dissolved in 1000 grams of water, as per the question, we got a solution, right? As per the question, we got a solution. And density of that solution which we got, that's equal to 1.15 grams per ml. What are we supposed to calculate? We are supposed to calculate molarity of this particular solution, right? We are supposed to calculate molarity of the solution. Tell me one thing. Among urea and water, which one is present in lesser amount? Urea. So urea has to be my solute. So mass of solute, which I'm representing with W2, that's 120 grams, right? Mass of solvent, which I'm representing with W1, that's equal to 1000 grams. Molar mass of solute, molar mass of urea. Urea formula is NH2CONH2. And do remember its molar mass directly from now onwards. It's 60 grams per mole, right? It's 60 grams per mole. So all this data is given. What am I supposed to calculate? Molarity. What is molarity? Mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters, right? Now tell me one thing. In order to calculate molarity, we already have W2 value. It's given to us. Molar mass of solute already I know. But volume of solution I do not know. Volume of solution I do not know. Now the point is, how do we calculate the volume of solution? To calculate the volume of solution, I'll be using this parameter. Density of solution is given. Instead of density of solution, can I write mass of solution in grams divided by volume of solution in ml? You know, density is equal to mass by volume. So density of solution is equal to mass of solution divided by volume of solution. That is equal to 1.15 grams per ml, right? Now tell me, what about the mass of solution? What about the mass of solution? Mass of solution will be mass of solute plus mass of solvent. So it comes out to be 1120 grams divided by volume of solution is equal to 1.15. So divided by 1.15 is equal to volume of solution, right? When you solve this, you will be getting the volume of solution as 973 ml. This is the volume of solution. So I got the volume of solution as well. Now put all the parameters in the equation. So it has to be W2, which is 120 grams multiplied with 1000 divided by molar mass of solute is 60. Volume of solution in ml is 973 ml. When you solve it, the value comes out to be 2.05. So 2.05 is going to be the molarity of the solution which we were supposed to calculate, right? Is it clear to everyone quickly? Is it clear? I hope this is super clear to everyone. Let me move on to one more question. Look at this particular question. Calculate molality of KCl aqueous solution. Calculate molality of KCl aqueous solution prepared by dissolving 7.45 grams of KCl in 500 ml of solution. As per the question, the mass of solute that's given to me is 7.45 grams. This is the mass of solute. Tell me, what will be the molar mass of solute? Molar mass of KCl, 39 plus 35.5. That comes out to be 74.5 grams per mole, right? As per the question, the volume of solution is also given to me, 500 ml, right? And density of solution is also given to me, which will be equal to 1.2 grams per ml. What am I supposed to calculate? I am supposed to calculate molality of the solution. Nowadays, students, do you remember any result to calculate molality? Mass of solute in grams multiplied by 1000, molar mass of solute, mass of solvent in grams, right? This is one of the results to calculate molality, if you remember. So what about W2? W2 is given to me. Molar mass of solute is given to me. Am I given with mass of solvent? I am not given with the mass of solvent. So I need to calculate the mass of solvent first. How exactly? You'll be using this particular parameter, that is density. So density of solution, I can write as density of solution is equal to mass of solution divided by volume of solution. So mass of solution divided by volume of solution is equal to 1.2 grams per ml. Now tell me, mass of solution will be equal to 1.2 into volume of solution. Volume of solution is 500 ml. So 500 into 1.2, it makes it 600. So I would say the mass of solution is 600 grams. The mass of solution is 600 grams, right? The mass of solution is 600 grams. If you got the mass of solution, what do I need here? I need the mass of solvent. You got the mass of solution. You know the mass of solute. Solution ka mass minus solute ka mass. That gives me the mass of solvent, right? So mass of solvent will be 600 minus 7.45, which will be 592.55 grams. So this is basically the mass of solvent, right? So all the parameters you have now. So put all the parameters in this equation, get the molality of the solution. Nothing else. Yeah? Is it clear till here? Quickly let me know in the chats, people. Let me know in the chats if all the things are clear till here. Perfect. All right. One more question we have. One more question we have. What mass of water should be added to 16 grams of methanol to make its mole fraction 0.25? What does it mean? See, imagine that this is a container. This container, it contains 16 grams of methanol. It contains 16 grams of methanol. Now, as per the question, we have to add water into this container. We have to add water into this container. And we have to add water till, we have to keep on adding water till the mole fraction of methanol, till the mole fraction of methanol becomes how much? Till the mole fraction of methanol becomes 0.25, right? So basically there are 16 grams of methanol in the container, and I need to keep on adding water. I will keep on adding water continuously till the mole fraction of methanol becomes 0.25. Now I have to check how many grams of water should be added to make the mole fraction of methanol as 0.25. I'm assuming that in order to make the mole fraction of methanol 0.25, let's assume that X grams of water are introduced. For example, in order to make mole fraction of methanol as 0.25, let's assume that I need to add X grams of water, right? Now you tell me one thing. There are 16 grams of methanol and X grams of water in the container. Can you let me know how many moles of methanol are there in the container? Mass of methanol in grams divided by molar mass of methanol, 32 grams per mole. The value is 0.5. Number of moles of water in the container will be equal to mass of water in grams divided by molar mass of water. So these many moles of water are there in the container. So can I say I need to add basically these many moles of water? I need to add basically these many moles of water in the container. Then only mole fraction of methanol will become 0.25, right? Now tell me one thing. What is mole fraction of methanol? It is number of moles of methanol divided by total moles. Total moles involves number of moles of methanol plus number of moles of water in the container. And this value is equal to 0.25, right? Now, number of moles of methanol in the container, that's 0.5 divided by 0.5 plus X divided by 18. This value is equal to 0.25. You got one equation which contains one unknown. Unknown as X. When you solve this X, you get the value exactly as 27 grams. So I would say 27 grams of water should be added to 16 grams of methanol. Then only mole fraction of methanol will become 0.25, right? Is this super clear to you? Yeah? Perfect. One more question. Calculate the molality. Calculate the molality of aqueous solution in which mole fraction of solute is equal to 0.2. So we have got a solution in which mole fraction of solute is 0.2. We are supposed to calculate molality of the solution. And it is an aqueous solution. That means the solvent which we have used, that is water. Now, my dear students, just tell me one thing. Have I given you any result? Have I given you any result which connects molality with mole fraction? Just say yes or no in the chats. Just say yes or no in the chats. Have I given you any result which connects molality with mole fraction? I gave you one result a few minutes back only, if you remember. If you remember. I told you Molality of the solution is equal to mole fraction of solute multiplied by 1000 divided by 1 minus mole fraction of solute, and this is molar mass of solvent. This was one of the results which I gave you. Now tell me, molality of the solution is equal to chi2 value, that's 0.2 multiplied by 1000. 1 minus 0.2 is 0.8. 0.8. Molar mass of solvent, molar mass of water, that's 18 grams per mole. Solve the equation, get the molality of the solution. Isn't it simple, people? Isn't it absolutely simple now? Yeah? And this is the question which is your homework. This is your question which is your homework. Molarity of the solution is given. This is your solute. This is your solvent. Density of solution is given. You need to calculate molality first, then weight by weight percentage of solute, then weight by volume, then mole fraction of solute, then ppm of solute, then ppb of solute. I would want all these answers in the comment section afterwards when the video ends. Right? When the video ends. Or do share me the solution on my Telegram channel, t.me/WASSIMSIRCHAM. You can share your responses over here as well. Perfect? Can you solve these questions? Say yes or no. Say yes or no quickly. Can you solve all these questions? I think let's take a break. Let's take a break till 8:15. Right? At 8:15 we'll start again. We have got some important topics to discuss now, right? So I want you guys to be fresh and I want you guys to be back till 8:15. Till then you can have tea or whatever, right? But be back because we are going to discuss something really amazing now, something really interesting, which is going to be used in your equilibrium as well, right? So be back sharp at 8:15. Till then, right? You have your snacks or whatever or tea and get freshened up. Yeah. See you at 8:15, people. Take care. But be back, okay? Be back. So what's up, guys? Are you back? Are you back? Are you back? Are you back? Yes. Welcome back, guys. Welcome back. Yes, Sahil, JE students can also watch this. Absolutely. Okay. Tell me, is every single thing clear till here? Tell me, is every single thing clear till here or not? Yes. Perfect, people. So let's try to understand one more important topic, that is molarity of dilution, right? First of all, before talking about molarity of dilution, let me make you understand two basic things. My dear students, do you remember how did I define molarity? In the beginning, I told you molarity is equal to number of moles of solute divided by volume of solution in liters. This is the formula which I gave you a few minutes back, right? Molarity of the solution is equal to moles of solute in the solution divided by volume of solution in liters. Can I write the same formula in this format? Can I write number of moles of solute is equal to molarity of the solution multiplied by volume of solution in liters. This particular formula is important. So basically, from this particular formula, what do we get? We get number of moles of solute present in the solution. If you know the molarity of the solution, if you know the volume of solution in liters, you just need to multiply these two things. You will be getting the number of moles of solute present in the solution. For example, let's say you have got a solution whose molarity is 2, whose volume is 5 liters. I'm asking you, how many moles of solute are there in the solution? Molarity multiplied by volume. So you will say there are 10 moles of solute present in 5 liters of solution whose molarity is 2. As simple as that, right? So do remember this particular result. Whenever molarity of the solution is given, volume of the solution in liters is given, just multiply the two and get the moles of solute present in the solution. Yeah? Point number 1. Point number 2. In the same result, if you replace volume of solution in liters by volume of solution in ml, if you take volume of solution in ml here, then I won't be calling it as moles of solute. I'll be calling it as millimoles of solute. This is one more result, my dear students, which you need to remember, right? Molarity of the solution multiplied by volume of solution in ml. It gives me the millimoles of solute. Now you must be thinking, what are millimoles? Millimoles are nothing. You can write it like this. Number of millimoles is always equal to number of moles multiplied with 1000. That's all. Number of millimoles is always equal to number of moles multiplied with 1000. For example, let's say we have got 2 moles of any substance. You can say we have got 2000 millimoles of the same substance. Let's say I've got 10 moles of some substance. You can say we have got 10,000 millimoles of that particular substance, right? So do remember these few basic terminologies which I've mentioned over here. Now people, let's try to understand the molarity of dilution. Understand properly what exactly I'm going to say. Imagine that I have got a container over here. And for example, in this container, let's assume that I am keeping HCl aqueous solution. I've got an aqueous solution of HCl. That means in this container, there is HCl with water, right? So we have got a solution here. Now people, let's assume that molarity of this particular solution, which we have in this container, let's assume that's M1. Let's say volume of this particular solution in liters is V1. right? Let's assume molarity of this solution is M1, its volume is V1, right? Now, people, what exactly I'm going to do? What exactly I'm going to do? I'm going to add some extra solvent into this particular solution. I'm going to add some extra solvent in this particular solution. And in simpler words, the process of addition of extra solvent into a particular solution. That's what you call as dilution in simpler terminology. The process of addition of extra solvent into a particular solution, right? That's something which you call as dilution. So can I say I'm right now doing the dilution of this particular solution? Absolutely. Now we will tell me one thing. After the dilution is done, can you let me know what is the volume of this particular solution? The initial volume of the solution was V1. Now you're adding some extra solvent into it. Now the volume of the solution would have increased from V1 to V2 liters, for example, right? Since you know, molarity depends on volume. Molarity is inversely proportional to volume. If volume of the solution is increasing, that means molarity of the solution will be decreasing. The initial molarity was M1. The final molarity after the dilution, that is M2, right? So M1 is the molarity of solution before dilution. V1 is the volume of solution before dilution. M2 is the molarity of solution after the addition of extra solvent after dilution. And V2 is the final volume of the solution after the dilution is done, after the addition of extra solvent, right? So can I say before this arrow, we are having the case of before dilution, and after the arrow, we are having the case of after dilution, right? This is after dilution. This is the before dilution scenario. This is the after dilution scenario. Now, people, if I ask you, before dilution, molarity of the solution was M1, volume was V1. If I multiply these two things, can I say I got the moles of solute present in this particular solution before dilution? Absolutely. Now, after the dilution is done, the new molarity of the solution is M2. The new volume of the solution is V2. If I multiply these two things, if I multiply M2 with V2, can I say this particular term? It gives me the number of moles of solute present in this container before dilution or after dilution? After dilution, right? Now, people, I want you to think, what did we do? Can I say we added extra solvent into the solution? Did I do anything with the solute? I did not do anything with the solute. I did not add extra solute in the solution. I did not take the solute out of the solution. I did nothing with the solute, right? I just did something with the solvent. I added extra solvent. I did nothing with the solute. Can I say the number of moles of solute present in the container initially will be equal to the number of moles of solute present in the container finally, right? I just added solvent. I did nothing with the solute. Neither I added extra solute, nor I took the solute out. So can I simply say number of moles of solute before dilution, that has to be equal to the number of moles of solute after dilution? So this is the concept of dilution basically. The number of moles of solute before dilution, that has to be equal to the number of moles of solute after dilution. So can I say I got one particular result, M1V1 is equal to M2V2. This particular formula is something which you call as dilution formula. You call it as the dilution formula. You call it as the dilution formula. When do you need this dilution formula? In order to calculate the molarity of the solution after the dilution is done. Due to dilution, molarity changes. Due to dilution, volume of the solution changes. Eventually, molarity changes. To calculate the new molarity of the solution after dilution, this particular formula is used, right? This is what you call as dilution formula. Now, do remember one thing. Here you have got V1, here you have got V2. Either on both the sides, you'll take volume in liters, or on both the sides, you'll take volume in ml. If you are taking volume in liters on both the sides, then the concept becomes moles of solute before dilution will be equal to moles of solute after dilution. If you are taking volume in ml on both the sides, then the concept becomes number of millimoles of solute before dilution will be equal to number of millimoles of solute after dilution. Only one thing you have to remember. If you are taking V1 in ml, take V2 also in ml. If you are taking V1 in liters, take V2 also in liters. Eventually, liter, yeah, ml will get cancelled out only, right? It's not like you will take V1 in liters, V2 in ml. No. Units on both the sides should be the same. Okay, this is point number one. Point number two. If I ask you, what is the volume of extra solvent added? If I ask you to calculate volume of extra solvent added, how much volume of extra solvent you have added? Initially, the volume of solution was V1. And after that, you added some solvent into it. The new volume of the solution became V2. Initial volume of the solution was V1. The new volume became V2. So I would say final volume of the solution minus initial volume of the solution. That's going to give you the volume of extra solvent added, right? That's going to give you the volume of extra solvent added, correct? Now, dear students, the same concept I'm going to use in one simple question, and I'm damn sure you will easily solve it. Understand? Calculate the volume of extra solvent. Calculate the volume of extra solvent added to 200 ml of 2 molar solution. So basically, you have got a solution whose initial molarity is 2, whose initial volume is 200 ml. Now, as per the question, you are adding some extra solvent. After the addition of extra solvent, the new molarity, the final molarity after the addition of solvent is done is 0.2. Let's say the final volume of the solution is equal to V2. Right? Let's assume that. Correct? Since you are adding solvent to it, the new volume of the solution for example is V2. The final molarity of the solution is M2. Now, is this the case of dilution? Absolutely, this is the case of dilution. And in case of dilution, what do we use? We use the dilution formula. M1V1 is equal to M2V2. What is M1? It is 2. What is V1? 200 ml. What is M2? 0.2. And from here, you can easily get the value of V2. And V2 value is equal to 2000 ml. But what is this V2? This is the final volume of the solution. Am I supposed to calculate the final volume of the solution? No. I'm supposed to calculate the volume of solvent added. A few minutes back, I told you how to calculate the volume of solvent added. Just tell me that. Volume of solvent added is always equal to V2 minus V1. V2 is the final volume. V1 is the initial volume. The value comes out to be 1800 ml. So I must say, in order to change the concentration of this solution from 2 to 0.2, I need to add 1800 ml of water into it, right? 1800 ml of solvent is to be added to change the concentration of this particular solution from 2 molar to 0.2 molar. Clear, people? Let me know quickly in the chats if this is super clear. Let me know quickly in the chats if this is super clear. Now there is something called as molarity of mixing. Right now I was talking about the molarity of dilution. Now I'm going to talk about the molarity of mixing of non-reacting solutions. Have a look what it exactly means. Try to understand what it exactly means. Case 1. Case 1. I'm taking 2 containers. I am taking 2 containers over here. In the first container, I'm keeping HCl aqueous solution. In the second container also, for example, I'm keeping HCl aqueous solution. Right? I've got 2 containers which contains 2 solutions. HCl aqueous solution, HCl aqueous solution. Right? Now tell me, if I mix them, have you seen HCl and HCl reacting? First of all, tell me, are these 2 solutions reacting solutions or non-reacting solutions? They are not going to react. When you mix them, they are not going to react. This is acidic solution, this is acidic solution. They are not going to react when you mix them. But if this was acidic solution, this was basic solution. When you mix them up, then they would have reacted. Acid plus base forms salt and water. That's a different case. That's a different case. Here I have got two non-reacting solutions, right? My dear students, let's assume that molarity of this particular solution is M1. Volume of this particular solution is, for example, V1 liters. Molarity of this solution is, for example, M2. Volume of this particular solution is V2 liters, right? I have not mixed these two yet. Now tell me one thing. How many moles of solute are there in this particular container? You will say M1 multiplied by V1 liters, right? How many moles of solute are there in this container? You will say M2 multiplied by V2 liters. Have I mixed these two solutions yet? I have not. I have not. So is this the case of before mixing or after mixing? This is the case of before mixing. So can you let me know how many total moles of solute we have in both the containers before mixing? Total moles of solute in both the containers before mixing will be equal to M1V1 plus M2V2. These are the total moles of solute present in both the containers before mixing. Now, people, what you exactly are going to do, you are going to mix these two solutions. You are going to mix these two solutions. When you mix these two solutions in this final container, I will be getting a final HCl aqueous solution, which I'm calling as a resulting solution of HCl. Which I'm calling as the resulting solution of HCl. Now tell me one thing. What will be the volume of the final solution of HCl? Volume of this solution was V1. This solution V2. Now you're adding them up. You're mixing them up. Right? So the final volume of the final solution, which I'm representing with VR, will be simply equal to V1 plus V2 if the resulting solution is ideal in nature. Right? Perfect. Let's assume that molarity of this final solution is equal to MR. Right? Now tell me one thing. If I multiply MR with VR, if I multiply MR with VR, what do I get? Can I say I'm getting total moles of solute present in the final container before mixing or after mixing? After mixing. Yeah, after mixing. Now tell me one thing. Tell me one thing. What did I do? I just mixed these two solutions in this final container, right? Perfect. Can I say something like this? Since I had one, this was one solution, this was one more solution. It had solute in it. Even it had solute in it. Now you're adding both the solutions into the final solution, into the final container. Can I simply say, whatever solute was here in this container, plus whatever solute was there in this container, entire solute present in both the containers would have finally reached into this container because you're adding them up. So can I say number of moles of solute in this container plus number of moles of solute in this container will be equal to the number of moles of solute present in the final container, right? So what is the concept which I'll be writing over here? I'll write number of moles of solute before mixing. That has to be equal to number of moles of solute present in the final container after mixing. Agreed? How many moles of solute are there in the containers before mixing? It is M1V1 plus M2V2. Right? How many moles of solute are there in the final container after mixing? It is MR multiplied by VR. And instead of VR, you can write V1 plus V2. Right? This particular formula is what you call as mixing formula. Or you can call it as addition formula. Right? Right? Molarity of mixing of non-reacting solutions. Perfect? And my dear students, you should be able to make this particular result. You should be able to make this particular result. You should understand the concept behind it. Moles of solute in the first container plus moles of solute in the second container. Those entire moles of solute in both the solutions would finally reach into this container. So moles of solute in 1 plus moles of solute in 2 will be equal to moles of solute in 3. Because and finally, everything is going into this container. Right? This is case number 1. Let me deal with case number 2 as well. You get two types of questions here. For example, this is the first container. This is the second container. And this is the third container. Let's assume that. For example, this container contains a solution. Even this contains a solution. And this one, for example, only contains the solvent. Let's assume it like this. Let's say you have got HCl aqueous solution in the first container, HCl aqueous solution in the second container, and in the last container, there is only water present. There is only water present. So solution in the first container, solution in the second container, only solvent in the third container. So let's assume molarity of this solution is M1, volume of this solution is V1. Molarity of this solution is M2, volume of this solution is V2. And volume of water I'm representing like this. Okay. Now, tell me, will there be moles of solute in this container? Will there be some solute over here? Yes, because it's a solution. In solution, there will be solute and solvent. So there is solute here. Solute is present here also. Solute is not present here. It's pure solvent. Have I mixed these three containers yet? I have not mixed them yet. So tell me, how many moles of solute we have in all the containers before mixing? In the first container, it's M1, V1. In the second container, it's M2, V2. And in the third container, there is no solute. So these are the total moles of solute present in all the containers before mixing. Right? Now, my dear students, I am going to mix them up. I am going to do what? I'm going to mix them up. Right? So after mixing all these three together, can I say I'll be getting a resulting solution of HCl? I got a resulting solution of HCl. Tell me what will be the final volume of this final solution after mixing these three. That will be VR, which is going to be equal to V1 plus V2 plus volume of water which you have added, right? Let's assume that molarity of the final solution is MR. If I multiply these two, what do I get? MR multiplied by VR. It gives me the total moles of solute present in the final container before mixing, after mixing? After mixing, right? Perfect. What is the concept which I'll be using? Since I'm talking about mixing, right? I'm talking about mixing. So I would say number of moles of solute before mixing. It has to be equaled number of moles of solute after mixing. Or you can write the statement in terms of millimoles as well. Millimoles of solute before mixing should be equal to millimoles of solute after mixing, right? What are the millimoles of solute before mixing? It's M1 V1 plus M2 V2 is equal. Moles of solute after mixing, it's MR multiplied by VR. Multiplied by VR. And already you know, VR is nothing. That is V1 plus V2 plus V of H2. Right? Now you must be thinking, where do we use these concepts? I'll be starting exactly from the basics. Understand? I'll give you one basic, simplest question, which can be never asked in NEET. Just to make you familiar with the results. That's why I'm giving you this. Okay. 200 ml of 3 molar HCl solution is mixed with 300 ml of 2 molar HCl solution. Calculate the molarity of the resulting solution. Right? Can I say this is the value of M1? I'll say this is the value of M1. This is the value of V1. This is the value of M2. This is the value of V2. Right? Perfect. So I'm mixing two solutions. Which concept I'll be using? Volume is in ml. I'll say millimoles before mixing should be equal to millimoles after mixing. Right? Or let me use the direct result. Case number 1. M1V1 plus M2V2 has to be equal to MR multiplied by VR. Right? Perfect. Now what is M1? 200. What is V1? 3. M2? 2. V2? 300. Molarity of the final solution we have to calculate. VR, volume of the final solution, that will be equal to V1 plus V2. V1 is 200 and V2 is 300. Can I say I got one equation which just contains one unknown, right? MR. So from this particular equation, you can get the molarity of the resulting solution. Isn't it simple? Isn't it simple, people? Yeah? Isn't it simple? Quickly, people in the chats. Quickly, everyone. Perfect. Let me solve one more question. 200 ml of 3 molar HCl. So basically, we have got 200 ml of 3 molar HCl aqueous solution. So we have got HCl aqueous solution, right? Whose molarity I'm representing with M1, that is 3. Whose volume I'm representing with V1, that is 300 ml. Is mixed with is mixed with 300 ml of 2 molar HCl solution. So you have got HCl aqueous solution as well, whose molarity is equal to 2, whose volume is equal to 300 ml. Whose volume is equal to 300 ml. And the final volume is made up to 1500 ml. See, volume of this solution is 300, volume of this solution is 300. So if I mix these two, the volume of the final solution should be what? The volume of final solution should be 300 plus 300, that is 600. But as per the question, volume of the final solution is equal to how much? Volume of the final solution is equal to 1500 ml. What does that mean? That means I've added water with it as well. Right? Then only you would have got a resulting solution whose molarity is, for example, MR, right? And volume is 1500 ml. Perfect. I'm taking the case of ideal solution. Perfect. I'm not considering anything apart from ideal. Is this clear? So you can easily solve this question, right? M1 V1 plus M2 V2 is equal to MR VR. M1 is given, V1 is given, M2 is given, V2 is given. VR is also given. So you have to calculate MR. That's it. Right? Perfect. So it's simple, my dear students. Right? After mixing the two, right, including you have added some extra solvent as well. Well, while mixing these two, you got a resulting solution whose molarity you have to calculate, whose volume is given to me as per the question, that is 1500 ml. So again, I'll be using the formula M1V1 plus M2V2 has to be equal to MR multiplied by VR. This, and this is given. So MR you have to calculate. That's it. Yeah. Perfect. Moving on to one more question. The volume of water that must be added to a mixture of this and this to obtain a 0.25 molar solution of HCl will be. What does it mean? Try to understand. As per the question, you have got the HCl aqueous solution whose molarity I'm representing with M1, that is given to me as 0.6 molar. Its volume V1 is given to me as 250 ml. There is one more HCl solution. Whose molarity is 0.2, whose volume is 750 ml. Now, as per the question, the volume of water that must be added to a mixture. So you are adding some water as well. So there is one more container which, for example, contains V ml of water. Now you are mixing all these three together. While mixing all these three together, you'll be getting a final solution, a resulting solution. Molarity of that resulting solution is 0.25. Tell me what will be the volume of that resulting solution? Volume of that resulting solution will be V1 plus V2 plus V. So it has to be 250 plus 750. That is 1000 plus volume of water. Right? So is this case 1 or case 2? This is case 2. So again use the result. You already know. Case 2 result. M1 V1 plus M2 V2. It has to be equal to MR multiplied by VR. But VR is nothing. VR is 1000 plus volume of water which you have added over here, right? So this term given to us. Even molarity of resulting solution is given. So you just have to calculate volume of water added. So one equation, one unknown. That's it. Calculate the volume of water added. As far as I remember, the answer will be 200 ml. I think so. 200 or 250, something like that. Right? Perfect. So this is something which we were supposed to calculate. Calculate the volume of water added. 250 ml of water, 200 ml of water has been added. Then only the molarity of the resulting solution has become 0.25, has reached 0.25. Perfect. I hope this is clear to everyone. Now, my dear students, one last topic. Or wait, before giving you the last topic, I'm giving you one question as the homework. Homework question, you have to solve this. You have to solve this at the end of the session and let me know its answer in the comment section. 29% weight by weight solution of HCl whose density is given. So you can calculate molarity. Occupies 8 ml volume. So V1 is given. Final volume of the solution whose concentration becomes 0.4. So final molarity is given, you have to calculate final volume. That's it. So this is something which you can do. Right? This is your homework question. So let me know its answer afterwards in the comment section. Now guys, our last topic in the concentration terms, that is molarity of ions. How do you calculate molarity of ions? Before talking about molarity, before talking about concentration of ions, either you say molarity of ions or you can say concentration of ions, one and the same thing, okay? How do we get the concentration of ions? How do we get the molarity of ions? Before talking about that, you should know how electrolyte is dissociated in water. For example, let's say you have got NaCl. If you put this NaCl into water, how it will undergo dissociation? This is one, this is one. This one will be the power of sodium, will be the charge on sodium. This one will be the charge on chlorine. Now, how many sodium atoms do you have? One sodium atom. And this sodium is present in which form? It is present in Na+1 form. Plus, how many chlorine you have? One chlorine. And chlorine is present in which form? Cl-1. So this is how it will undergo dissociation. For example, you have got BaCl2. How will you dissociate it? Assuming all as a strong electrolytes. How will you dissociate it in water? Right? Make this 2 as the charge here. Make this 1 as the charge here. How many barium we have? We have got 1 barium. And barium is present in dipositive state. Plus, how many Cl we have? 2 Cl. And Cl is present in -1 state. Right? You have got AlCl3 for example. Perfect. This 3 is the charge here. This 1 is the charge here. How many aluminium? 1. And how this aluminium will get dissociated? As tripositive, right? How many Cl? 3. And Cl charge? -1. Simple. So in general, if I have got the electrolyte in this format, strong electrolyte for example, how are you going to dissociate it? Take this Y as the charge here. Take this X as the charge here. How many A particles we have? X. And A is present in +Y form. How many B particles we have? Y. B is present in -6 form. This is how you are going to dissociate, right? Perfect. Now tell me one more thing. Tell me one more thing. My dear students, already I told you number of moles of solute is equal to molarity of the solution multiplied by volume of solution in liters. One more thing. Number of millimoles of solute is equal to molarity of the solution multiplied by volume of solution in ml, right? Can I say molarity is equal to number of moles of solute divided by volume of solution in liters? Can I say molarity can be also calculated as number of millimoles of solute divided by volume of solution in ml, right? Someone is asking about normality. Normality I have taught in redox reactions. There is a chapter redox reaction in one shot I have taught before on this channel. Check there. There I have taught normality in detail. Because in order to understand normality, you should know equivalent mass. Equivalent mass ke liye you have to understand oxidation state. So all those things were discussed in the chapter. All those were discussed in the chapter redox reactions. Okay. So my dear students, what I'm trying to convey here, molarity can be calculated as molarity is equal to number of moles of solute divided by volume of solution in liters. One way. Second way, number of millimoles of solute divided by volume of solution in ml. Right? Just remember this. Why you have to remember this? There is a logic behind that. See. For example, you have got 200 ml of 0.1 molar BaCl2 aqueous solution. Right? You have got a container which contains 220 ml of 0.1 molar BaCl2 aqueous solution. What does that mean? That means BaCl2 you have introduced in water. Now you tell me, when BaCl2 will be introduced in water, how will it undergo dissociation? As Ba di positive plus 2 times Cl negative. Right? Now people, if I ask you, are you given with the molarity of this solution? Yes. Are we given with the volume of the solution? Yes. Molarity multiplied by volume in ml. Molarity multiplied by volume in ml. That gives me the millimoles of solute. Solute here is BaCl2. So how many millimoles of solute we have? Initially in the container, before the dissociation starts, initially there are 2 millimoles of BaCl2 in the container. Right? So this will be 0. This will be 0 because the dissociation has not started yet. Now considering BaCl2 as a strong electrolyte, let's assume that it has got 100% dissociated into its ions. So I'll be left with 0 millimoles of BaCl2, right? So 1 mole gives 1 mole. From 2 millimoles, you get 2 millimoles. Similarly, 1 mole gives 2 moles. From 2 millimoles, you get 4 millimoles. So my dear students, what did we get? We got the millimoles of Ba positive and millimoles of Cl negative present in the container at the end. We got the total millimoles of Ba positive, total millimoles of Cl negative in the container. For example, I'm supposed to calculate the concentration of Ba positive. I'm supposed to calculate the concentration of Cl negative in the final solution. What is concentration? Molarity, right? So basically, I'm supposed to calculate molarity of Ba positive in the final solution, molarity of Cl negative in the final solution. My dear students, tell me, how do we calculate the concentration of Ba positive, molarity of Ba positive? What you exactly have to do, it's going to be equal to millimoles of Ba positive divided by total volume of the solution in ml. Similarly, molarity of Cl negative, millimoles of Cl negative in the final solution divided by total volume of the solution in ml. Now tell me, how many millimoles of Ba positive are there in the container? 2. Total volume of the solution, that's 20. The value comes out to be 0.1. So this is the concentration, this is the molarity of Ba positive in the final solution. Tell me the molarity of Cl negative in the final solution. Millimoles of Cl negative, 4. Total volume of solution in ml, that's 20. 4 by 20 means 1 upon 5. 1 upon 5 is 0.2. So this is the concentration, this is the molarity of Cl negative in the final solution. Right? Simple. So do remember one simple thing. Whenever you are supposed to calculate the molarity of ions in the final solution, what exactly you have to do? First, you have to calculate millimoles of that ion in the solution. Once you get the millimoles of that ion in the solution, divide those millimoles by the total volume in ml. Done. Right? You have got one more way to solve it as well. Calculate the moles of ion in the solution and divide the moles of ion by total volume in liters. Right? Perfect. Hello, Shaju. Thank you. Let me give you one more example. Have a look. Understand properly. We are mixing NaCl aqueous solution with CaCl2 aqueous solution. So basically, there are two containers. One container contains NaCl aqueous solution, another one contains CaCl2 aqueous solution. Now add them in the same container. When you add them in the same container, can I say I'll be getting a final solution? Resulting solution, right? I'm getting the final solution, I'm getting the resulting solution. My dear students, I'm asking you to calculate the concentration of Na positive in the final solution. I'm asking you to calculate the concentration of Cl negative in the final solution. I'm asking you to calculate the concentration of calcium dipositive in the final solution. These are the things which I'm asking you to calculate. Can you just let me know once in the chats if all of you can see me? Is it lagging or something? People, can you all see me, hear me? Okay, no lagging. Right. Basically, my laptop is lagging then. I don't know why. I don't know why. Anyways, leave it. Okay, have a look, people. So first of all, when NaCl goes into water, how will it undergo dissociation? NaCl in water dissociates as Na positive plus Cl negative. Tell me how CaCl2 would have undergone dissociation as Ca di positive plus 2 times Cl negative, right? Perfect. Now tell me one thing. Initially at time t is equal to 0. Do we know the molarity of this solution? Yes. We know its volume in ml as well. So molarity multiplied by volume in ml. It gives me the millimoles of solute. Solute here is NaCl. So millimoles of NaCl is this into this, which comes out to be 20. So we have got 20 millimoles of NaCl in the beginning. So this has to be 0. This has to be 0. Now assuming NaCl has got completely dissociated. So this is 0. This will be 20. This will be 20. Because 1 mole gives 1 mole. 20 millimoles are going to give me 20 millimoles. So what did we get? What did we get? I calculated the millimoles of Na positive and millimoles of Cl negative, which are coming from NaCl. Which are coming from NaCl. Right? Now, tell me how many millimoles of CaCl2 we have initially. Molarity multiplied by volume in ml. So we have got 30 millimoles of CaCl2 initially. This is 0, this is 0. Now this will be 0. 1 mole gives 1 mole. 30 millimoles are going to give me 30. 1 mole gives 2 moles. 30 millimoles are going to give me 60. So what did I get? I got the millimoles I got the millimoles of calcium dye positive and Cl negative, which are coming from CaCl2. Can I say basically I'm mixing these two solutions? So can I say all these ions are finally going into the same container? All these ions are finally going into the same container. So in the final solution, calculate the concentration of Na positive, which will be equal to millimoles of Na positive present in the final solution. Na positive is only coming from NaCl. This has got nothing to do with Na positive. So how many total millimoles of Na positive we have? 20 divided by total volume in ml. 300 plus 200 makes it 500. So this is the concentration of Na positive in the final solution. If I ask you to calculate the concentration of Cl negative in the final solution, Cl negative is coming from here as well as Cl negative is coming from here. So how many total millimoles of Cl negative are there in the final solution? So 20 plus 60 makes it 80. So these are the total millimoles of Cl negative in the final solution divided by total volume in ml. 300, 200 is 500. So this is the concentration of Cl negative in the final solution, right? Similarly, if I ask you, what is the concentration of calcium dye positive in the final solution? You will say total millimoles of Ca dye positive in the final solution, that is 30 divided by total volume in ml, that's 500. So this is the concentration of calcium dye positive in the final solution. I hope this is clear. Right? Let's try to solve one more question on the same concept. Try to understand. Calculate the molarity of H positive when the following solutions are mixed. So you are mixing these solutions, right? See how this H2SO4 would have undergone dissociation. 2 times H positive plus SO4 dye negative. Tell me how this one would have undergone dissociation, this HCl. H positive plus Cl negative. How this HNO3 would have undergone dissociation? H positive plus NO3 negative, right? Perfect. Now tell me one thing. Initially at time t is equal to 0, do I know the molarity of the solution? Do I know the volume of solution in ml? So this multiplied by this, it makes it 150. So I've got 150 millimoles of H2SO4 in the beginning. So this is 0, this is 0. Now this will be 0. 1 mole gives 2 moles. 150 millimoles are going to give me 300 millimoles. So there are 300 millimoles of H positive, which are generating in the final solution due to H2SO4, right? How many millimoles of HCl we had in the beginning? This multiplied by this, 600 millimoles, 0, 0. Now this is 0, this is 600. What is the 600? These are the millimoles of H positive which are being liberated, which are generating in the resulting solution from HCl. HNO3, this multiplied by this. So we have got 600 millimoles of HNO3 in the beginning, 0, 0. Now this is 0, this should be 600. So 600 millimoles of H positive are coming from HNO3, right? Now what am I supposed to calculate? Concentration of H positive in the final solution will be equal to. So tell me in the final solution how many millimoles of H positive are there? How many millimoles of H positive are there in the final solution since you are mixing them? Total millimoles, 300, 600, 600. How much? 6, 6, 12, 350. So 1500 millimoles of H positive in the final solution divided by total volume of the solution in ml. Okay, so this is 2 molar, 2 2s are 400. Let's make it 3 molar, 3 2s are 6. Now it's okay? Okay, 1500 millimoles of H positive finally in the container divided by total volume 100 plus 200, 2, 2, 4, 5. So this is 500 ml. So this is the final concentration of H positive in the final solution. Yeah? Perfect. Now we will one more question. Look at this particular question. The molarity of Cl negative in an aqueous solution, which has 5.85% weight by volume of NaCl, 22.2% weight by volume of CaCl2, and 5.35% weight by volume of NH4Cl will be. Try to understand this particular question. So basically, assume that you have got a container in which you have got an aqueous solution. The container contains an aqueous solution. And in this aqueous solution, what all things we have? We have got NaCl, we have got CaCl2, and we have got NH4Cl as well. In the aqueous solution, we have got NaCl, we have got CaCl2, we have got NH4Cl as well. Try to understand what I'm going to say. What do we have to calculate? The molarity of Cl negative in the final aqueous solution. First thing, weight by volume percentage of NaCl is given 5.85. Weight by volume percentage of NaCl is given 5.85. What does that mean? That means 5.85 grams of NaCl are present in 100 ml of aqueous solution. So basically, as per the question, we got to know that we have got 100 ml of aqueous solution. As per the question, we got to know that we have got 100 ml of aqueous solution. And in this 100 ml of aqueous solution, what is the mass of NaCl present? Mass of NaCl present is 5.85 grams. This is the mass of NaCl present. Similarly, 22.2% weight by volume, CaCl2. What does that mean? That means 22.2 grams of CaCl2 are present in 100 ml of solution. So there are 22.2 grams of CaCl2 as well. Similarly, there are 5.35 grams of NH4Cl as well in 100 ml of solution. Volume of the whole solution is 100 ml. 5.85 grams of NaCl are present in 100 ml of the whole solution. Similarly, 22.2 grams are present in 100 ml of solution. Similarly, these many grams are present in 100 ml of solution. Now tell me one thing. Tell me how many moles of NaCl are there in the container. Mass of NaCl divided by molar mass of NaCl. So we have got 0.1 moles of NaCl in the container. Given mass divided by its molar mass, which is 58.5. Similarly, how many moles of CaCl2 are there in the container? Mass of CaCl2, molar mass of CaCl2. Value will be 0.2. How many moles of this? Mass of this divided by its molar mass. The value will be 0.1. Right? Because molar mass of CaCl2 will be 111 grams per mole. Molar mass of NH4Cl will be 53.5 grams per mole. Right? So I got to know the moles of NaCl, moles of CaCl2, moles of NH4Cl present in 100 ml of the aqueous solution. Correct? Correct, people? Now tell me how this NaCl would have undergone dissociation. NaCl would have undergone dissociation as Na positive plus Cl negative. How many moles of NaCl we had? 0.1. In the beginning, this will be 0, this will be 0. Now this will be 0 because 100% dissociation. 1 mole gives 1 mole. From 0.1, you get 0.1. 1 mole gives 1 mole. From 0.1, you get 0.1. So you got to know the moles of Cl negative which are there in the container. Coming from NaCl. Right? Now, how CaCl2 would have undergone dissociation? Calcium di positive plus 2 times Cl negative. So how many moles of CaCl2 we have? 0.2. This is 0, this is 0. Now this is 0. 1 mole gives 1 mole, 0.2 gives 0.2. 1 mole gives 2 moles, 0.2 gives 0.4. These are the moles of Cl negative which are present in the aqueous solution which have come from CaCl2. Now similarly, how this NH4Cl would have undergone dissociation? NH4 positive plus Cl negative. How many moles of NH4Cl we had? 0.1, 0, 0, 0, 0.1, 0.1. These are the moles of Cl negative, right, which are present in the solution and which have come from NH4Cl. Now you tell me one thing. How many total moles of Cl negative are there in the container? 0.1, 0.4, 0.1, which makes it 0.6. So these many total moles of Cl negative are present in the container, right? Container means the aqueous solution. What is the volume of aqueous solution? Volume of aqueous solution is 100 ml. Can I say 100 ml of aqueous solution contains 0.6 moles of Cl negative? 100 ml of aqueous solution contains total 0.6 moles of Cl negative. Tell me, what about 1 ml of aqueous solution? Can I say 1 ml of aqueous solution will contain 0.6 divided by 100 moles of Cl negative? What about 1000 ml of aqueous solution? 1000 ml of aqueous solution will contain 0.6 divided by 100 multiplied by 1000. The value is 6 moles of Cl negative. Tell me, what did I get? I got the moles of Cl negative which are present in 1000 ml of solution. That means I got the moles of Cl negative which are present in 1 liter of aqueous solution, and moles of Cl negative present in 1 liter of aqueous solution. That defines its molarity. So molarity of Cl negative in the resulting solution is equal to 6. Just remember, how did we define molarity? Mass of solute present in 1 liter of solution. I was supposed to calculate molarity of Cl negative. That means I was supposed to calculate moles of Cl negative present in 1 liter of solution. So basically I got to know 6 moles of Cl negative are present in 1 liter of solution, right? So this is something which I will be calling as molarity of Cl negative. I hope this is clear. I hope this is clear. Yeah? Perfectly done? Perfectly done? This question, I'm sure you can easily solve this one, right? So let me give you this question as well as the homework, right? You can give it a try. You can give it a try easily. Yes, it's easy. Be careful with one thing, but be careful with one thing. You're mixing Na2SO4 with HCl, with CaCl2. There might be a reaction between some of the reactants. Be careful with that. There might be a reaction between some of the reactants. Be careful with that. Be careful with that. Will you be able to solve this, or should I show this question? Just let me know in the chats once. Do you want me to show this question, or you will give it a try? Quickly. Quickly, people. Let me know quickly in the chats. Will you give it a try, or you want me to solve this question? I'll say yes or no. It's completely okay. There's no need to feel shy or something. I want everyone to write it. I want everyone to write it. Will you give it a try, or I want everyone to write it quickly, guys, quickly. Okay, you give this question a try and do write its answer in the comment section of the video as well, right? If you were unable to solve this question, by chance, let me know on my Telegram, right? Let me know on my Telegram. I'll send its solution. Okay? I'll send its solution to you. Perfect. So guys, with this, your concentration terms, including this dilution, mixing, etc., it is again done and dusted, right? So with this, I'll be taking a leave. I'll see you guys on Tuesday, and on Tuesday, we shall be starting a new chapter that is going to be chemical kinetics. Chemical kinetics will be completely done and dusted in 2 lectures, right? Starting from the basics itself. Okay? Right? So with this, I'll be taking a leave, and the session PDF you'll be getting in the Telegram. Okay? So take care. God bless you all. See you. Bye-bye.